which obviously you don't need to, but I'm going to rewrite the formula, which is on the board. You guys can see I'm adding two angles, correct? These are like your u and your v. So basically, the sum of two angles, based on the formula that's written on the board, is cosine of u times cosine of v. And then it's minus sine of u times sine of v. Now, wouldn't you guys agree we can kind of think of like sine of pi over 4 as this is like our u and this is our v? Yes? No? Yeah? OK. It's kind of like this cosine of u plus v. You're just adding the two angles. Now, it'd also be important for us to know which quadrants these are in. 7 pi over 4 is in which quadrant? Fourth. And this 5 pi over 6 is in the second quadrant. Good. So now what we're basically going to do, the step that I wanted you guys to show me, is now let's go ahead and plug these in. So the first step I'd want you guys to show, you don't need to show this, but the first step would be cosine is to rewrite this. Do not evaluate it. Well, let's show the work. Cosine of u is 7 pi over 4 times cosine of v, which is 5 pi over 6, minus the sine of 7 pi over 4 times the sine of v, which is 5 pi over 6. OK? So basically, you're given a formula, which you're going to have on a test, and I give you the problem. You're basically just plugging it in. Right? That's the easy part. I think everybody in this class should have no problem doing this. Now, the next part is going to depend on how well you know your unit circle, because I warned you about that at the beginning of this chapter. If you're still struggling with the unit circle, this is not going to be a very fun chapter section, because look how many times we have to evaluate the unit circle. 4 times, and you're going to want to do it like this. OK? So 7 pi over 4, hopefully you guys know that's going to be square root of 2 over 2, but it's in the fourth quadrant, so cosine is positive. Cosine of 5 pi over 6 is in the second quadrant. We're thinking of cosine, so 5 pi over 6, that's going to be a negative square root of 3 over 2. Now, I like to use parentheses. I'm not telling you have to use parentheses, but a lot of mistakes come from students not using parentheses, so I'd recommend doing that. Minus. Again, when you're subtracting, you don't have to do this, but I like to do, when you're subtracting a quantity, I like to sometimes also use brackets, just to make sure I get my signs correct. Sine of 7 pi over 4, that's also square root of 2 over 2, but it's in the fourth quadrant, so that is negative. And then sine of 5 pi over 6, which is in the second quadrant, so it's positive. So that's a 1/2. OK? So here, easy step. Here, the unit circle step. The last step is, for your grade for at least a free response, would be to kind of simplify this. Now, all I'd expect you guys to do is multiply these. So you can get this to be negative square root of 6 divided by 4, right? Because can't we break apart the product, and we can just bring them back together, right? So that's square root of 6 minus 4. Here, that's a negative, so that turns into a positive square root of 2 over 4. Now, should we subtract these? Should I do square root of 2 minus square root of 6? Square root of negative 4? No? Shouldn't do that? Shouldn't do that? Well, first of all, typically, this is perfectly fine. If you guys want to rewrite them in a order, typically we like to write things as positive. The positive first. And it would even be better just to rewrite these with a common denominator, which I don't think is too difficult for you guys. But why can't I subtract square root of 2 minus square root of 6? Why is that not? Why can't I subtract these? Guys, it's the same problem we just did. Square root of 9 minus 4 does not equal the square root of 9 minus the square root of 4. We didn't subtract these, right? You can't subtract these under the radical. So you can't do it. They're not the same radicand. OK?
Is it simplified?
That would be a simplified answer. Or that's an answer that's acceptable to me.
Okay.
It's not technically simplified, though, for at least multiple choice problems. So for multiple choice problems, they look at the problem. They're going to want to factor out common terms. So let me show you guys a couple. Now, again, so for me, I'm looking for this work. OK? If I get that, that's an M for me. However, let's just kind of work through some of the problems on multiple choice. Let's look at some common terms that they have. Do you guys see how? So we have, let's use that one. Do you guys see how these both have a common? Now that's a positive, right? So it turns positive. Do you see how they both have a square root of 2? Mm-hmm. Do you see how they both share a 4? So if you factor out a square root of 2 over 4, you are going to be left with a negative square root of 3 plus 1. Or, to rewrite that another way, square root of 2 over 4 times 1 minus the square root of 3. So you don't need to go to this step for me on the free response. However, when you guys are doing a multiple choice, you're more likely going to see it like this. Factored, simplified out. That's simplified fully. Question?
Can you not square that entire thing? And then it'd be a lot more. The radical 2 minus radical 6 over 4.
What do you mean, just like square? Well, again, remember, if you're squaring the right side, you have to square the left side. So don't forget that.
Okay.
And then even if you did do that, even if that was fine and you did want to square it, remember that's you got to that's a binomial. That's square root of 2 minus square root of 6 times the square root of 2 minus the square root of 6. You're not going to get rid of radicals there either. So that wouldn't be your answer either. Anyways. But we're going to practice that in a second because we're going to have some groups. Actually, you're the group that's actually going to work on that. So now